Hello friends, in this section we will see division algorithm for polynomials. In the previous section we have seen that a polynomial could be written as product of its factors. For example, a quadratic polynomial ax square plus bx plus c can be written as x minus m into x minus n. Now if one of the factors is given to you, we can easily find the other factor by dividing the quadratic polynomial by this given factor. Similarly, for a cubic polynomial ax cube plus bx square plus cx plus d, we can express this as x minus m into x minus n into x minus p. Now if one of the factors is given to us, we can easily divide the cubic polynomial by this given factor to get the product of the remaining factors. And the product of the remaining factors will be a quadratic polynomial, and we have just seen how to factorize a quadratic polynomial. By doing so, we get the remaining factors as well. Now to do all of these, we need to know one important thing. And what is that? We need to know how to divide polynomials. Only if we know how to divide the polynomials, we will be able to find the unknown factors. Let's say you want to divide the cubic polynomial 3x cube plus x square plus 2x plus 5 by a quadratic polynomial 1 plus 2x plus x squared. Let's do this division step by step. I would encourage you to follow these steps along with me. So get your notes ready. Alright, so what's our first step? Our first step is to arrange the terms of divisor and dividend in decreasing order of their degrees. Doing so, we can express the division as shown. Now you are ready to move on to your second step. Divide the highest power in dividend by the highest power in divisor. In this case, the highest power in dividend is 3x cube and highest power in divisor is x square. When we do the division, we get the value as 3x. So here comes your step 3. We just got the first term of the quotient as 3x. So carry out the division process as usual. When you do that, we get the remainder as minus 5x squared minus x plus 5. Divide the highest power of your new dividend by the highest power in the divisor. When you do that, you get the value as minus 5. We just obtained the second term of the quotient, that is minus 5. Carry out the division process as usual. When you do that, you get the remainder as 9x plus 10. Notice that the degree of the remainder that we just obtained is lesser than degree of the divisor. Now this is your clue to stop the process, because we won't be able to carry out division at this point. That's it. You have just divided two polynomials. In the first chapter, we discussed that dividend can be written as divisor times quotient plus remainder. Do you remember the name of this rule? Yes, that is Euclid's division lemma. By applying Euclid's division lemma to the dividend and divisor here, we can write this as shown. See the usefulness of Euclid's division lemma? We just don't use it for numbers, we can use it for polynomials too. Let's formally state Euclid's division algorithm for polynomials. If p of x and g of x are any two polynomials, with g of x not equal to 0 of course, then we can find polynomials q of x and r of x such that p of x is equal to q of x into g of x plus r of x, where r of x is either 0 or has a degree lesser than that of g of x. Now that you have understood how to apply division algorithm for polynomials, let's try to apply this in one of the questions. Let's say we want to find all the zeros of the given polynomial where two zeros are given as minus 5 and 3. So how do we go about it? We are given a fourth degree polynomial, and per our conceptual understanding, we know that this polynomial will have at most 4 zeros. Let's say m, n, p and l are 4 zeros of this polynomial. This means x minus m, x minus n, x minus L and x minus p are 4 factors of this polynomial. So we can express the polynomial as x minus m into x minus n into x minus L into x minus p. Now we are given two zeros, minus 5 and 3, which means two of the factors are x minus minus 5 and x minus 3. X minus minus 5 can be written as x plus 5. So the two factors are x plus 5 and x minus 3. Using this information, we can express our fourth degree polynomial as shown. We can rewrite this expression by multiplying x plus 5 and x minus 3 and we get something like this. Observe this equation closely. If we divide the fourth degree polynomial on the LHS by the quadratic polynomial on the RHS, we get the product of unknown factors. So let's do this division by applying Euclid's division algorithm. When we do that, we get the result as x square minus x minus 2 as shown. Now x square minus x minus 2 is a quadratic polynomial and we very well know how to factorize this quadratic polynomial. When we factorize it, we get the result as shown. There you go. We get the unknown factors of the fourth degree polynomial as x minus 2 and x plus 1. This means 2 and minus 1 are the unknown zeros of this fourth degree polynomial. Therefore, zeros of the given polynomial are minus 5, 3, 2 and minus 1. Make sure that you completely understand the steps shown here. If you have any doubts, feel free to use the doubt section. We will be happy to help you. So that's it guys. We have just completed our second chapter. Make sure that you practice a lot to gain a solid understanding of these concepts. Happy learning!